Welcome to Train Signal. You're watching the DNS Concepts video for Windows Server 2003. In this video, we're going to take a look at several critical concepts to DNS, talk about why they're important, and then how they affect how we configure our DNS servers. Let's get started by taking a look at our first concept, the DNS namespace. Now, the DNS namespace is just the hierarchy or the way that DNS organizes resources in order to find them. Okay, and think of a namespace like a naming scheme. Okay, so we're going to organize something. We got to come up with some way of organizing it, how we're going to, sort these things out. That's pretty much what the DNS namespace is all about. So more of a complex name than what it's really talking about. Now, when we're dealing with this DNS namespace, keep in mind that it's capable of organizing millions of computers from within one database. Okay, and an example of that is the internet. Namespaces are created on local networks as well. Okay, so if we're talking about namespaces, let's put this in a context a little bit here. Well, we have the internet namespace, and that internet namespace, of course, includes domains like Microsoft.com and Google.com, ones that we're familiar with. This is the public internet namespace. Well, on our individual networks as well, for example, here we may have a local namespace, trainsignal.local. Let's say that we decided to name our domain that. And within that namespace, which would be referred to as a private namespace, okay, we can do anything we want. We can create our own host records. We can break it down and create different zones and domains and all sorts of things. Okay, now some of these concepts may be beyond what you're familiar with right now, but we'll cover this stuff in due time as we go through this different course. Okay, let's take a look at an example of a DNS namespace here, just to get a better feel for how this whole thing works. Now, this is just a general breakdown of the public namespace that we were just referring to before. And it is pretty important that you have a good understanding of this namespace. And then also down here, we'll take a look at how the name is broken down, okay, how this name is organized within DNS. Now, the public namespace starts at the root domain. And we have a little tiny dot up here. And that dot there that we're referring to, make it a little bit bigger, okay, that is the root domain. So it always starts with dot. So actually, when you type in a URL, let's say you type in www.microsoft.com, there's actually an assumed trailing dot there. Just like this namespace here, I could put a dot right there, and that would be the full name because it's referencing the actual root up above. From the root domain, okay, we have what we call our top-level domains. And these top-level domains are what we're looking at right here. And those include .com, .net, .org, .edu, .uk. Here I've got NZ for New Zealand. These are just some examples. Of course, we've got some of the other ones, .mil, .tv, and then all the different country codes that we may have as well. Now, one thing that some students have had before have been confused about, and I want you to be perfectly clear about, is .com, okay, which we're all familiar with here. This is a top-level domain. Well, so is .uk. Okay, so if you were, let's say, over in Great Britain and you were setting up your own web company, wanted to create your own website, well, you could try to register a name with .com if that was available, but if it were not available, you could also use .uk. So, for example, we'll skip down here to our second level domains. eBay has a domain name, ebay.uk, and of course, this is going to be more catered to the United Kingdom audience. Okay, and this is a totally different name than this one over here where we see we have ebay.com. Okay, here's .com and .uk. And if we trace down this hierarchy, this DNS namespace, you see that we go from the root to com, and then it breaks down to all the different domains here, and these are called second-level domains. Okay, second-level domains, that's what we're dealing with here. And if you're familiar with this, take a look. Here's trainsignal.com, our domain, for example. And this is a domain that we can register. So I can go to a registrar like Network Solutions or GoDaddy and actually register this domain name myself. Okay, so that's something to be familiar with. You can't do that with these top-level domains. Okay, these are set by the Internet Governing Body, ICANN. Okay, and right now, there's nothing you can do about creating a top-level domain. Okay, if you want to create a second level domain though, as you see right here, we've registered this and we now have possession of this second level domain. Underneath your second level domains, this is where we start creating all of our different subdomains, and that's what these are down here. Okay, I've created a bunch of, or a couple different subdomains here. I've got CHI for Chicago.trainsignal.com, and then NY for New York, NewYork.trainsignal.com. Now, these domains, these subdomains, these are under complete control of us here, and we don't really have these domain names, but if we wanted to create subdomains, we could easily do this. Okay, and at this point here, these are now considered private. Okay, so I can do anything I want with these. These could be behind a firewall, and these just might be within our organization, or they could actually be subdomains up here. Maybe we've got a real elaborate website, and we've got it broken down into subdomains, like sales.trainsignal.com, or we might have, UK.trainsignal.com if we broke it down by country. Okay, let's not get too far out of scope here, so let's focus on this name here first before we really do much else. It's very important that you start getting a feel for these names that you see right here. For example, we have xp1.chi.trainsignal.com. Now, always to the far left, this is going to be our computer name, also referred to as a host name. Okay, so that's the actual name of this computer right here, xp1. Okay, the rest of this, trainsignal.com, this is actually the DNS domain name, or also referred to as a DNS suffix. Okay, and you should be familiar with this DNS suffix because I think some people are confused by what it is. Well, it's just everything past the host name here, and Microsoft often refers to this piece here as the DNS suffix. Okay, so I'd be familiar with that. Okay, so anytime you see that written down, we've got our computer name, and then we've got our DNS domain name or DNS suffix to the right. Okay, and this breaks down a namespace fairly well. It gives you a pretty good feel for what the public namespace looks like. Okay, so sitting here from a client machine, then let's do a brief example. If we wanted to resolve a name and actually talk to a web server at harvard.edu, so I might type in here from my computer www.harvard.edu. Well, the path it's going to take, first I'm going to talk to a local name server, and we'll really focus on this, a little bit later on in a future video. But first we talk to a local name server. If it's not resolved locally, we climb up this path here, and then from the root domain, this root domain here, which is represented by 13 different DNS servers, our root DNS servers, well, what's going to happen is they're going to break this resolution down, and first they're going to resolve this name down to .edu. Okay, so we're passed along here, and then we're going to talk to a .edu server. Okay, and this is just another DNS server that's representative of .edu. Once we talk to the .edu server, we're going to ask that server if it can resolve Harvard. Okay, so now we're going to have harvard.edu, and then what will happen? We'll get the appropriate IP address, and then we'll go down and we'll talk to the Harvard DNS servers. Okay, and then once we get here, the Harvard DNS server should be able to tell us where www is. Okay, and then we would be supplied with the IP address of www.harvard.edu. Okay, and then once we have that IP address back here, then we would talk directly to, we don't have to go up through the DNS chain anymore, we could talk directly to this web server that would be sitting over here. Okay, the Harvard web server. Okay, just to give you a feel for that. We're going to talk about this specifically later on in one of the later labs, Lab 3 and Lab 4. We're really going to take a close look at how this whole public DNS system would be set up so we can connect to a web server. Okay, let's go back over here to our DNS concept screen here and take a look at our next concept that we want to talk about. Okay, and that's name resolution. If you look at name resolution here, we see that this is done by either using WINS or DNS, just to use a couple different examples. Okay, and it's really important that you understand what name resolution actually is. Okay, both WINS or DNS, both of these are pieces of the TCP/IP infrastructure. Okay, and TCP/IP communication, when we're using IP addresses to talk back and forth, must be working before WINS or DNS is going to function correctly. Okay, let's just pop up a network here just so we get a good feel for what we're talking about. Now, this isn't a real detailed network, but basically what we're saying here is if server 1 and server 2 wanted to communicate with each other, the very first thing I have to worry about is getting my TCP/IP infrastructure set up correctly. Okay, and I want to worry about my IP addresses. So here you can see I've got a 192.168.1.100 IP address, and up here I have a 192.168.1.200 IP address. And both of these have subnet masks of 255.255.255.0, okay, using our CIDR notation. Well, I want to make sure that these machines can talk. So that's what's going to happen. These machines should be able to ping to each other. The default gateway is set up appropriately, so I should be able to talk over here to this server that's running ISA server. So we should be able to ping over here to the internal network card. Our client here should be able to connect. All these machines should be able to communicate using IP addresses first and foremost before we do anything or care at all about DNS or WINS. Okay, because we see a lot of people mess with DNS settings and messing with the preferred or alternate DNS settings on a client, and that does not matter if your IP address isn't configured correctly. Okay, so just realize that DNS and WINS are TCP/IP enhancements. Okay, they sit on top of the actual IP addressing scheme, and without that IP addressing scheme working underneath, DNS and WINS are really useless. Okay, so keep that in mind just for general knowledge and also for troubleshooting. Okay, don't start off trying to ping using a domain name. Okay, for example, I might try to ping server 2 here. Start off trying to ping the actual IP address first. If that works, then start worrying about name resolution issues. Maybe then you can determine that you have a DNS problem. Okay, going back here again, we have one more thing we actually want to look at relating to name resolution. Okay, and these are the DNS resolution steps. Now this is something that you may or may not be familiar with, but it's something I think that's pretty important to understand when you're doing DNS troubleshooting. And this is basically, in a nutshell, what happens, okay, when you're sitting at a computer, your desktop computer maybe that you're watching this from right now, when you type in www.google.com. Okay, how do you get that IP address? How does the DNS server work to provide you with the IP address for google.com? Okay, well the first thing that happens is your system is going to check its local host file, okay, the local host file. And you may or may not be familiar with this, but every Windows system is going to have a host file. It's located in the system root, system32 drivers, etc directory by default. Okay, and when we say system root here, it just really depends upon what Windows system you're running. On the local system here, which is an XP system, well this system here has the directory, the system root is on C, and it's the Windows directory. Okay, then we have a system32 drivers etc directory. Okay, well this host file can be modified for quicker name resolution, but it's not very efficient and it's not really used too often anymore. Okay, this was used in the earlier days of the internet when there wasn't that many computers on the internet. Host files were used to provide just a static way of getting IP addresses for all the different servers that were out there on the internet. Okay, but nonetheless, your system, when you do a name resolution, you type in www.google.com, the first thing that happens, you're going to check your local host file and see if that entry exists within this text-based file. Let's go look at this file real quickly here. Okay, I'm going to go to my computer, which I have up here on my desktop. We're going to go to our C drive, the Windows directory, and this is representative of the system root. Okay, and then from here we're going to go into system32. Okay, from within system32 now we're going to go down to our, skipped it, drivers folder. Okay, then the etc folder. Okay, and then right here you see that we have a hosts file. And it's got one of these generic Windows icons. That's because there is no file extension with hosts. Okay, it's just host.nothing, so there is no file extension. So to open this up, I'm just going to right-click it, then do a open. I'm going to select which program I want to open it up with, and I'm going to use Notepad to open this up, just a simple text editor Notepad. And then here we get a sample of what this host file looks like. Okay, now all of these up here, these are just examples and they're commented out with these pound signs. Okay, so these are not going to be applied. The host file is actually not going to work when we're using this. Okay, but down here, this is the first entry that's actually within this host file. And you can see the format that's used. We have an IP address, 127.0.0.1, okay, and then we have the actual host name itself, which is localhost. Now, you may be familiar with this IP address. This is the loopback IP address. This is if you want to test your own TCP/IP software on your own system. Okay, remember we can go to a command prompt here and type in ping 127.0.0.1, okay, and we just ping ourselves here to see if our TCP/IP software is set up correctly. Okay, well, let's try something different. If this host record truly works, okay, then we should be able to ping localhost, okay, and then by pinging localhost, it should then resolve this to an IP address, and we should be pinging that 127.0.0.1 IP address. Let's try it out. Okay, ping space localhost. I ping it, and look what it does here. Okay, I didn't put in XP1 or anything, but it does resolve that back down to an IP address, and then it also gives us the actual host name, XP1, the computer name that's associated with it, and the ping is successful. Okay, let's experiment with this just one more time here, just to give you another example. Let's assume here that we want to use the local IP address, which should be 192.168.1.1. Let's check it out, though, to make sure we've got it correctly configured. Okay, you see right here, 192.168.1.1. Okay, and now what we're going to do, we're going to create an entry here in our host file. Okay, and in this host file, you know, we can really use anything that we want. Okay, so I'm just going to put in here first the IP address. We'll make that match up. Okay, and then let's put in here, I don't know, how about dog? Okay, I'm going to save this file. Now I've saved the file. Okay, and here, if I type in ping dog, look what it does. It actually goes to that host file first, resolves that back down to the IP address that we just talked about here, okay, and then we're able to ping it. Okay, so the host file can be used if you're accessing a server or a client computer quite frequently on a network. You could actually put in a file here, a record here, into the host file for quicker name resolution. Now, are you going to notice it? Probably not. Okay, it's not going to be that big of a difference as far as name resolution speed's concerned. I mean, think about it. You go out to google.com and you're not really waiting around too long to get to that website, so you probably won't even notice it. Okay, but this could be used on a local network situation, you know, a place where bandwidth is somewhat more limited. Then maybe it would be helpful. Okay, I'm going to go ahead and remove this entry from here. Save this back to how it was, and then close out of our actual host file. So just an example of what we're talking about when we said the host file. Okay, so we first check with the host file. If the entry is not there, so let's just once again assume that we're going to www.google.com. If the entry is not there, the next thing we do is we check the local cache. Okay? And the local cache, in a DNS client, it actually checks its local DNS cache before it forwards the request off to a DNS server. Okay, and if you're not familiar with what a cache is, it's just basically, it's taking the information. Let's say that we just went out to google.com. It's going to take that information, the domain name, www.google.com, okay, and then the IP address that we got back, and it's going to store that here locally in a section of memory. Okay, and then when we do that, next time we go back to google.com, we won't have to go out to the internet to get that IP address once again. We're going to have it here locally. Okay, that's the theory behind this. Now, when we do this, it wouldn't be a very good thing if once we went out to a website, we cached that IP address permanently. Okay, so for example, if we went out to google.com again, we got the IP address for google.com's website. Well, what if they change their IP address? They switch ISPs, or for whatever reason they change the public IP address. If we had that cached permanently, well, we'd be getting that bad name resolution. We'd end up going back to Google, you know, trying to go out to the old Google IP address. Okay, and that's why we have what's called a TTL. And that's what we see right here, time to live. Okay, a time to live basically is set on the client side, and what it tells us is or I'm sorry, it's set on the server side. When you go to a DNS server and you actually get a record from the DNS server, it tells you how long you can actually cache that entry for. But it's going to tell you exactly how long on the local machine you can cache that domain name and IP address match for. Okay, so a couple things to talk about here. If you want to look at your DNS, your client machine's local cache, first thing you have to do to view the cache is just run ipconfig/display DNS. So let's take a look here at what this might look like. Okay, ipconfig/display DNS. I hit enter here, and right now it's not real exciting. Okay, if you look here, I've got a, here's one entry in my cache for local host. Okay, and it's pointing right back to this machine using a loopback address. And that's really all I have in my cache. Okay, let's go around here. Let's go out to some websites, if it worked. Let's check our IP settings here real quick and see what we've got, and we'll go out to a couple of websites and we'll see how we can populate this cache. Okay. That's, oops. Actually, what we're going to do right now, we've got a DNS server set up here locally, so this should point us in the right direction. 1.230. Okay, so we'll try this out again here and see if we can't get out to the internet. There we go. Okay, so we get out to msn.com. Just go to another couple websites. Go out to Google. Okay, let's go out to Dell. Okay, so we just gone out to 3 websites. This is just to simulate web browsing going on. If I do that same command right now, ipconfig/display DNS, check that out. Okay, just those few entries, and we get a whole lot of different entries here. So starting from up top again, you start looking down at these. Okay, some of these, no clue what these are even related to. Okay, something to do with the ISP or some DNS server that we were forwarded out to. Okay, and some of these are going to be actually, when you go out to a DNS server, okay, even though we're trying to get to, here we have msn.com, along the way we got to go through other DNS servers. So as long as we're going there, we might as well cache the IP address of those other DNS servers as well. And that could very well be what we see here when you have this spe.atdmt.com. Okay, but here you see MSN. You got several entries for MSN. They have different name servers, so we have a record for a name server here at 245, 234, 254. Okay, these are actually their web servers, sorry. Google, here's a Google entry, here's another MSN entry. Okay, and here's one entry for Dell. Okay, now if we were to wait 5 minutes, okay, just depending upon what the time to live is, this one's really short here, so that one's going to be almost instantly gone. This is the time to live right here, these numbers that we're looking at. Let's take a look. Let's focus on one of these time to lives. Let's look at, let's go to our Google entry, since we were talking about Google before. Okay, here we have Google, and the time to live here is marked at 279. So let's remember this for a second, and we're going to come back here. So I'm going to run this command once again. Okay, exact same command I just ran a second ago. Now we're going to look at this command. Okay, here's where I first ran it, and we're going to go down to our Google entry. Okay, right here. Notice the difference. Okay, now we're down to 176. These are seconds ticking off. Okay, so it's down to 176. When this entry expires, this will no longer be cached. Okay, we'll no longer have the IP address of google.com. Okay, so if I run this again just to show you one more time, it's probably been 15-20 seconds since we ran it. If I go back up here to Google, okay, now it's down to 145. Okay, 31 seconds it took. So eventually, if we waited here, for another 2 minutes, this entry would be completely expired. Now, some of these are actually longer. If you look up here, they're 737 seconds. Look at this one, 510,000 seconds. Now luckily this is just a local entry, so that's no big deal. But what can happen, depending upon where you're going, you can get what's called a poison cache. And a poison cache would be, let's say that, similar to what we were talking about before, this Google entry that we had here. What if this entry was set up to be 14 days? Okay, just however many seconds that ends up being. But they gave us the wrong IP address. Okay, so we end up getting mapped back to the wrong IP address. In that case, we'd have what's called a poison cache, because we would be resolving the name correctly, but when it came time to actually go to the IP address we were given, it wouldn't work. Okay, so that's what we call a poison cache. In cases like that, where your cache seems to be corrupted, what you can do is run another command, ipconfig / flush DNS. Okay, and we run this, and it tells us right here, successfully flush the DNS resolver cache. And now if I run a command that we ran 2 times ago, display DNS, to display our DNS cache, we're back to that original entry that we spoke of before. Okay, so we've flushed out that cache completely. Now bear in mind, you don't have to do this all the time, because if you just don't use your computer for a while, the cache is going to be flushed out on its own. But this is really for those special cases when you're troubleshooting DNS problems, DNS issues. You need to flush that cache and make sure you don't have any poisoned DNS entries within your local cache. Okay, so we're back here to screen, and we check the local cache. Now we come down here to the third option, okay, the DNS server. We forward it off to the DNS server. So here, once again, we typed in www.google.com. We checked our host file, not there. Checked our local cache, no entry. Now it's time to actually forward this request off to the DNS server. Okay, so the DNS server gets this request, and before it forwards it or sends it off to any other DNS server, it's going to check its local cache as well. Okay, so that's real similar to what we're talking about here. So it checks its local cache. If it does not enter or exist there, okay, this entry for google.com doesn't exist, the next thing it does is checks its own zones. Okay, if the DNS server is configured with a zone, it will check the requested domain name against its zones first before sending the request off to another DNS server. Okay, so it's going to check to see if it has google.com as one of its forward lookup zones. If it's not there, it can't do anything about it, and then it's time to forward that request then off to an internet DNS server. Okay, and that really depends upon how we have our DNS server configured as to what happens next. And we're going to save that for later on in this series here and talk about, what happens, whether we're using a forwarder or root hens. Okay, and speaking of root hens, we can talk about these right now. Root hens, okay, these are a file, or is a file that's provided within the DNS software in Windows 2000 and 2003, and actually other DNS software as well, not to, limit this to 2000 and 2003. This file points to the 13 root servers out there on the internet, and it allows for public name resolution. Okay, so right now I've got a DNS server that's configured, and I really didn't do anything at all, and it automatically can resolve host names to IP addresses. Okay, and we're going to go take a look at this in more detail in a second, but a couple more facts. Number one, the file name is cache.dns, as we see right here, and it's located in the system root system32 DNS directory. Okay, and once again, system root, this is referring to whatever the system root is on our particular system. Okay, so in Windows 2000, this would be WinNT. In Server 2003, this is Windows, is the actual system root. And we're going to be working with Server 2003 machines, so when we go over and look at this DNS server, it's just going to be c:\Windows\system32\DNS. Okay, and this file can be managed using Notepad just like we could with the host file, and extra entries can be added if you want to. Not advised, but they can be added if you choose to. Let's go take a look. Okay, so we're going to connect over to server 3 here in our test network. Okay, and server 3 is a domain controller. It's just sitting out here by itself. It's running a DNS server as well. Okay, and this is the first and only domain controller for a domain called greenlizardbooks.com. And what we're going to look at first we're going to go take a look at the root hints file that we were talking about a second ago. Okay, so we went to C, Windows. Now we're going down to System32. Then you open up the DNS directory. Okay, and right here you see we have a file called cache.dns. If I right-click this, open with, and then use Notepad, you can see that we have this cache.dns file. Okay, you should change nothing if connected to the internet. Edit this file only when updating root name server list is released. Okay, and we really, this is pretty outdated. It's not a big deal. This would be something that would be automatically taken care of if these root servers changed. This is something that you would get in the form of a Windows update. Okay, so this isn't something you really need to modify. Now, here you see we have 13 different root name servers, and that number, they're lettered, but there are 13 different servers. And if you look here, we have what are called name server records, a.root-servers.net, okay, and they're just assigned letters, as I mentioned before. And then we have what's called a glue record, okay, or in this case, it's also a host record, and it's mapping this name, see it duplicated here, to this IP address. Okay, so this is actually one of the root servers. We could, do an NS lookup to 198.41.0.4, and we could start resolving names directly using this A root server here. Okay, and then here you see the 13 other root servers. Some of these are more informative as to where they're located. This one I'm looking at here, terp.umd.edu. I'm making a guess that this is the University of Maryland Terrapins here with the UMD and the .edu. We've got one located, hosted by nasa.gov. Go down here further down, we've got one hosted by the Army, army.mil, VeriSign. Okay, there's one here in Japan. I'm not sure where these other ones are located. I'm assuming the majority of them are located in the United States, but I'm sure there's other ones that are scattered across the world. Okay, but that's what these are, 13 root servers that service the internet all over the world. Okay, so that's what we're talking about here. Now, like I said, you don't really want to touch it or deal with it here. We're going to go take a look at it from a DNS perspective and see where you can actually see this file here. Okay, and what we need to do here is actually go to the properties of the server. Okay, and see here you have a root hints tab. If you click here, these entries match up to the exact same entries that you just saw in that file. Okay, and as I mentioned, there's really nothing for you to do. If you wanted to edit this, you could, but not recommended. You're not going to accomplish anything by editing it. You could add a server in here. Okay, if for some reason you wanted to, modify this, but your best bet is to leave this alone. Okay, but these are root hints. Now, this is important to realize because when we're looking at this, we can actually set up our DNS quite simply and get it working without configuring anything else. You've probably heard of forwarders before, maybe even configured forwarders. Well, if you want a simple setup for DNS, the easiest way to do this, okay, all that we have to do is just make sure that two things are going on. Number one, let's make sure that our IP settings are correct. Okay, so here I'm sitting on the DNS server itself. Okay, and you can see this IP address on this machine is .230. Okay, mask, default gateway. It's definitely got to be pointing. It's got to be able to connect out to the internet. So if you remember back to our network diagram, this machine's pointing out to the internet through our firewall. And then here's a real important setting. It's got to be pointing to itself for DNS. Okay, so if it's trying to resolve DNS names, very important this is pointing to itself for DNS, as you see right here. Okay, now that this is configured, the next thing that you have to do, that's what we call step one. Step two is to just simply install DNS. Okay, if you just install DNS, that's all you have to do, and then your root hints are set up and configured without you doing anything else. Okay, and if your client machines are pointing to server 3, okay, so then, on their preferred DNS server settings, so, for example, we could go over to XP1, and this is actually what I did, but we can go over to XP1, go to its network card, properties, TCP/IP, and just configure the preferred DNS server on XP1 to also point to server 3 here, 192.168.1.230. If we point it there, then it's also going to be able to use this DNS server and resolve its host names down to IP addresses. Okay, we're back over to the XP1 machine. Let's close out some of these windows here so we can think. Okay, and take a look back here at our file once again. Okay, we're down to, got through DNS namespaces, name resolution, root hints. The next thing we're going to work on are SRV records. SRV records are DNS record types that allow clients to locate resources on the network based upon what services they're looking for. Okay, and as an example, if a client logs on to a network, okay, so it logs on, it's attempting to log on to a Server 2003 Active Directory network, what it has to do first is locate a domain controller. Okay, so this DNS client is going to query a DNS server, and it's going to look for an SRV record that's going to help it locate domain controllers on the network. Okay, and these SRV records, what they're basically doing is they're lumping all the services that are provided on the network together, and what you're looking for then, it'll kind of dole out an IP address for a domain controller, or in some cases an LDAP server, just depending upon what service that you're looking for. Okay, now a couple things to remember when we're dealing with these. Number one, they're required for Active Directory domains. Okay, so you don't really need to worry about this if you're dealing with an all Microsoft solution. If you have Windows 2000 or Server 2003 DNS servers, they do include support for SRV records, so you won't have to worry about this too much. However, if you're using a third-party solution or a Unix solution, Unix Bind, Linux, if you're using an older version of Bind, it may not support these SRV records, which absolutely have to be used in Active Directory. Next thing, which is good news, they are automatically created. So there's really, not too much mess with these. I think the only thing you might have to do every once in a while is do some troubleshooting. And we'll take a look and just give you a feel in a second here for how you can find these, what they look like, what they're actually doing. Okay, and preemptive, before we go look at these, SRV records describe the service. Okay, Kerberos, protocols, TCP or UDP, DNS location, so the actual server name where it's located. So in this case, you may be looking for a domain controller running Kerberos. It's running the UDP protocol, and it's located at server1.greenlizardbooks.com. Okay, just to give you a feel for what we're dealing with. Let's go take a closer look at SRV records so you're more comfortable with them. So we've connected back over to server 3 here. And we're just going to go right back up to DNS again. And from within this DNS console, we need to open up our forward lookup zones. And we see right now we do have one zone that's currently in existence, and that's for greenlizardbooks.com. Underneath greenlizardbooks.com, we have our SRV records. Okay, and we have 4 different folders here that our SRV records are located in. We see a folder for our _MS DCS, and we have sites, TCP, and UDP. Okay, we're not going to thoroughly exhaust these, a little bit outside the scope of what we're trying to do, but what we will do is get a better familiarity with these. If we open these up, what we start to see, we have domain controller, domains, GC is for global catalog, and PDC is for PDC emulator. Okay, so when we're looking at this right now, if we start opening these up and drilling down here a little bit more, okay, now it's broken down into sites. There's only one site, and by default it's default first site name, so that's why you see that. Open this up, and underneath TCP, we have a couple services. So what we found out here within this Green Lizard Books domain, okay, if we're looking for a domain controller in this particular site, okay, underneath TCP/IP, so this is a protocol that's being used. Here's the Kerberos service. This is what we're going to need anytime we're authenticating to a domain controller. And then here's the LDAP service. Okay, and if you look here, if we open up one of these records, I'm just going to double click it. What it shows us here are a couple things. If we take a closer look at this, we see we have the site name. Okay, and then we start looking closer, we actually see the computer name built right into this, or down here actually, the host offering this service. Okay, but up here we do see the domain name greenlizardbooks.com has been incorporated. This is the actual domain if somebody's trying to log on to it. What it's basically saying is, here's the SRV record. We've located a domain controller, a Kerberos server for this particular domain, and here it is. Okay, server3.greenlizardbooks.com. Now we can do the same thing with some of these other ones here if we drill back down. And since there's only one domain controller, it's not going to look a lot different. But just for argument's sake, we have domains. If you look here, we have the GUID or GUID, Global Unique Identifier. Okay, and this is the identifier for this particular domain. If I open this up, TCP, LDAP. Okay, well here we see that we've got a server 3 machine that we can do our LDAP queries to, Lightweight Directory Access Protocol, and it's for this domain once again, greenlizardbooks.com. If we had a forest structure that had more domains in it, you'd see a little bit more detail here. It'd be dividing this up a little bit more. Since we don't, right now we basically have one forest, one domain, and one domain controller just for demonstration purposes. You don't see a lot of differences between these. Okay, but moving on down here, once again, these SRV records, they're going to help client computers and servers locate domain controllers, domains, global catalog servers, and then here we have our PDC emulators. Okay, here we have sites. If you're looking for sites, this is how we're going to locate different sites. Okay, and then our different protocols, TCP and then UDP. Okay, we also have domain DNS zones and then forest DNS zones. We're going to talk about these a little bit later on. Okay, so SRV records, like I mentioned before, a little bit confusing. I think the first time I was looking at them, I was a little bit lost by what they were for. But after you read a little bit about them, explore them a little bit, the confusion goes away a little bit. Okay, and the good news is you really don't have to manage them. Troubleshooting every once in a while, you might have to look them up, be familiar with what they're talking about. But for the most part, you're not going to have to be doing anything with them. They're automatically created. Okay, a couple more terms here. First one is authoritative. Okay, this is more of a definition. There's not a lot to look at, but you'll see this term thrown around a lot, authoritative. And what it's referring to is the name servers that are responsible for a particular DNS zone. Okay, the name servers that have an NS record created for them. And one or more servers can be authoritative for a zone. Let's actually connect back over to server 3 just to demonstrate this. Okay, when we're looking right here, and we open up our greenlizardbooks.com zone, we see that we have an NS record for server 3. Okay, and what this does, this makes this machine authoritative over this particular domain. Okay, server 3 is authoritative. It can give me authoritative information about this greenlizardbooks.com domain. You may have 10 other DNS servers within this domain, but not all of them have to necessarily be authoritative. They could be secondary DNS servers. Okay, so right now, since we only have one DNS server, this is the only one that's authoritative over this domain. Okay, then our last concept, zone. You're probably familiar with this, but just to make sure, zones, DNS database piece that holds host records and other resource records as well. When we're talking about zones, we can create forward lookup zones or reverse lookup zones. Okay, and that's what we were dealing with over here. We're going to be spending a lot of time with zones in all the different lab videos that we're going to be going through here. So this is something that if you're not comfortable with right now, we will get you comfortable with how zones work. But, in a nutshell, here's a zone right here that we've created for our namespace, greenlizardbooks.com. Okay, and I threw that namespace term out there around once again, but keep in mind what we're referring to. We're setting up a domain here locally. I've got this company here, greenlizardbooks.com, and we just chose a name. Okay, it doesn't have to be, anything. You could use anything you wanted here. Okay, if we wanted to here locally on this system, we could have used greenlizardbooks.local. So don't be confused by this naming scheme. I think that throws people sometimes, trying to get a feel for whether to use .com or .edu, or is it going to conflict with my public domain namespace, that sort of thing. That's something we will go into a lot of depth on in the Lab 3 and Lab 4 videos, just to really differentiate what we can do when we're setting up our DNS environment. Okay, but in a nutshell, this is a zone. When we create a zone, it creates a database, and the database file, if we take a look at the properties, okay, is actually called, Where is it at here? Thought it was referenced in here. Doesn't show it. Okay, I was under the assumption that it would show it here, but the file itself anyway is just greenlizardbooks.com.dns. That's the name of the actual database file. Within that database, okay, we've got our host records. Here's a host record here, okay, and then other resource records. We have a name server record, an NS record, start of authority record. We can create other records like MX records, CNAME records. Okay, so a whole slew of other things that we can create. But in a nutshell right now, zone, when we create the zone, it's creating a database. Inside that database are all the different resource records we need to change names down to IP addresses. Okay, so that's pretty much what we've got when we're dealing with a zone. Okay, that finishes out our concepts here then, and it also finishes up this video. Okay, so hope you found this helpful. And then we'll see you back here real soon. Next, we're going to get started with the Lab 1 video. In the Lab 1 video, we're going to be walking through how to set up standard primary and standard secondary zones. We're going to walk you through how to do this in Server 2003, the installation process, zone transfers, etc. So after watching that video, you should have a thorough understanding of exactly how DNS works, at least the beginning portions of it in 2003.